Section 2.1 in college algebra is going to cover the distance and midpoint formulas. So we want to start out talking about just the coordinate plane here. And I want to remind you where the quadrants are. So when we label quadrants, we use Roman numerals. So quadrant 1 starts in the upper right section. In quadrant 1, all of your x coordinates are positive and all of your y coordinates are positive. Of course, this is your x-axis, and the positive numbers are on the right end and the negative numbers are on the left end, seeing as how that middle is 0, 0. Our y-axis is here, positive y coordinates above the axis, negative y coordinates below. So that's quadrant 1. Quadrant 2 has negative x coordinates and positive y coordinates. Quadrant 3 in the lower left has negative x coordinates and negative y coordinates. And then quadrant 4 has positive x's and negative y's. Like I said, this ordered pair in the center here, right there, where the two axes cross, is called the origin, and its ordered pair is 0, 0. So when we go to plot a point, our points can either be in a quadrant, in quadrant 1, 2, 3, or 4, or they can be on an axis. If they're on an axis, then technically they're not in any of the quadrants. So we can ask questions like, in which quadrant would x be greater than 5 and y be less than or equal to 2? So x being 5 is going to be over here. 1, 2, 3, 4, 5. There's x is 5. So bigger than 5 over here, and y is negative 2. Y is less than or equal to negative 2. So we'd be over here to the right of 5, below 2 in quadrant 4. The distance formula. The distance formula is going to help us find the distance between 2 points, any 2 points on the coordinate plane. Traditionally, we use a formula that uses x sub 1, y sub 1, and x sub 2, y sub 2. So that's a formula you can definitely memorize. Usually people say the distance is the square root of y sub 2 minus y sub 1 squared plus x sub 2 minus x sub 1 squared. I don't usually state out that formula in that formal of a manner. I will just take the square root and I'm going to subtract the y's from each other and then square it. I'm going to subtract the x's from each other and square it, and then I take the square root of that whole thing altogether. Why does it work this way? Well, the distance formula is based on the Pythagorean theorem. So if I have any two ordered pairs and I draw a right triangle that connects those ordered pairs, we'll pretend that's a right triangle. Then remember the Pythagorean theorem says that if I take a squared plus, well, this will be a, plus b squared, I get c squared. Well, c is the distance that I'm looking for. So I want to label c as the distance that I'm looking for, d, in my quadratic, or in my distance formula. So then that would be the c squared part. But since we just want to get d by itself, we would need to take the square root when we're done. So let's see. D squared is going to be c. Then we have to do a squared plus b squared. Well, the distance from here to here, this point is y2 tall. This point is y1 tall. So to get how long this piece is, what we're going to need to do is subtract the y values. Or you could do y2 minus y1. So the length of A is found by subtracting the y values. So I will subtract the y values. And then because of the Pythagorean theorem, I have to square that. And then the distance from here to here, this ordered pair is starting at x sub 1, and it ends over here at x sub 2. So technically, this ordered pair in the corner is x sub 2, y sub 1. So then to find that length, we would subtract the y values. X values. So then the length of B is going to be found by subtracting the x values. And then since it's the Pythagorean theorem, I have to square that. And then to get d by itself, we'll take the square root. Now you don't really need to worry about why all of this works. Just focus on the distance formula, but I've found it helps me personally to understand where something's coming from, if that can be something that's explained. So sometimes I like to do that when I have time. So there you go. That's why the distance formula works. But again, feel free to just straight out use the Pythagorean theorem in either of these two versions that you prefer. I mean the distance formula. So here's our distance formulas. Okay, midpoint formula. So the midpoint formula is based on the midpoint being halfway between two ordered pairs. So the midpoint would be right here in the middle, meaning that it's the same distance from x2, y2 to the midpoint as it is from the midpoint to x1, y1. So here's our midpoint. And it is halfway between 2 points. To find that midpoint or the middle distance, what we're going to do is we're going to average the x values and average the y values. So when I do midpoint formula, again, I don't like, for my own personal, I don't like to use x sub 1s and y sub 1s like that. I just say that I'm going to average the x values and I'm going to average the y values. Then keeping in mind that that's what we're really doing, the average x value is going to be found by adding the two x values and dividing by 2. So I'm going to take the two x values and add them, divide by 2. Average y values, I'm going to add the two y values and divide by 2. So there is your midpoint formula, but I just go by the guideline of averaging them. But you do whichever one you're going to be most successful with remembering and being able to do reliably. Okay, let's look at a couple of examples here. So we're going to start off by finding the distance between these two ordered pairs. One of them has fractions and the other one has a negative. So this will be fun. So to find that distance, we're going to do the square root of, and we're going to subtract the x's and then square it. We're going to subtract the y's and square it. We're going to add those two values together and then take the square root. So subtracting the x's. Here's my x's, 1/2 and 2. So I can either do 1/2 minus 2 or I can do 2 minus 1/2. It does not matter when we're working with the distance formula and the midpoint formula. The time that it's going to matter is when we are finding slope. So be careful once we get to slope, and I'll remind you. No worries on that. And then we're going to subtract the y's. So again, up to us which order we want to do that. I'll probably do -1 minus 4/3. squared. Then I'm going to add those two together and take the square root. So let's just remember how to add fractions and subtract, right? We have to have a common denominator. So if I'm doing 2 over 1 minus 1 over 2, I need a common denominator. That is going to be 2, so I'll have to change that into 4 over 2 minus 1 over 2. That's going to give me 3 halves. So then I have 3 halves squared. When I square a fraction, well, or anything actually, I mean, I'm taking that number times itself. So when I do 3 halves squared, I'm going to do 3 times 3 and 2 times 2. So that's going to give me 9/4. Okay. I still have my square root here, and I still have to add my y's. So -1 minus 4/3, -1 over 1 minus 4 over 3. Again, I have to have that common denominator, so I'll do times 3 and times 3, so that's -3/3 minus 4/3, which will be -7/3 squared. When I square -7/3, I'm taking it times itself. -7 times -7 is 49. 3 times 3 is 9. Okay, so far so good. Next, we're going to need to add those fractions that are inside the radical. And again, need common denominators. So the LCD between 4 and 9 is going to be 36. So I'll need to multiply 49/4 times 4 over 4, 49/9 and 9/4 times 9 over 9. So then that's going to put me at 81/36 plus, 49 times 2 is 98. So 196/36. And then add those together. 196 plus 81, 277. So 277/36. Now, when you're simplifying radicals that look like a fraction in this way, we want to remember that we could rewrite this as the square root of 277 over the square root of 36, which would then simplify to the square root of 277 over 6. So this would be the distance between those 2 points. And then they want us to find the midpoint. So the midpoint between the x, this ordered pair 1/2 4/3 and 2 -1. So remember that midpoint is found by taking the average x's and the average y. So in averages, we're going to add the two values together and divide by 2. So we're going to do the x's. We will take 1/2 plus 2 divided by 2. And then for the average y's, we're going to take 4/3 plus -1, or -1 plus 4/3 over 2. Okay. Now we already have kind of our common denominators over here to the side. We're just going to have different signs. So 1/2 plus 2 would be 1/2 plus 4 over 2. So that is going to make 5 over 2. So we have 5 over 2 over 2. And then 4/3 plus -1 would be 4/3 plus -3/3, which will end up being 1/3 over 2. Now here we have something that I like to call stacky fractions. I think they're called complex fractions, but I call them stacky fractions. And we have a strategy for working with stacky fractions. Okay, when we're working with stacky fractions, what you want to do is multiply the stacky denominator, like the one that makes it weird, to the top and bottom, meaning numerator and denominator. So we're going to do that 2 times in this problem. So here we have 5 halves divided by 2. So this one right here, this 2, is the stacky denominator. So I'm going to multiply the numerator by 2 over 1 and the denominator by 2. I'm just not putting that over 1 because there's not a fraction. So what happens when I do that is that these 2's will cancel, or you can think of it like I'm going to multiply and get 10 over 2. So when I do that, I'm going to end up with just a 5 in my numerator, and then 2 times 2 will give me 4 in the denominator. I'm going to do the same thing for the y-coordinate. So looking at my y-coordinate, the stacky denominator is this 3. So I'm going to multiply by 3 over 1 in the numerator, and by 3, it would be over 1 in the denominator. So when I multiply this straight across, I get 3 over 3, which simplifies to just 1. And in the denominator, 3 times 2, which is 6. So my midpoint would be 5/4, 1/6. Keep this stacky fraction concept kind of in the back of your mind because we'll use that throughout. Okay, what if they asked us to prove that a right triangle is formed by these 3 ordered pairs? Well, in order to be able to prove that, we're going to need to use the distance formula to find the lengths of those 3 sides. So we will use the distance formula to find the length of the 3 sides. Okay. Then we know that right triangles follow Pythagorean theorem, a squared plus b squared equals c squared. So once we have the 3 sides, we're going to check to see if the Pythagorean theorem works for those 3 sides. So we're going to do, for our first side, we'll do 1, 5, and 1, -2. So for our distance formula, remember, we have square root. We're going to subtract the x's and square that in one parenthesis, subtract the y's and square that in the other, add those together. So we're going to have 1 minus 1 squared plus 5 minus -2, or -2 minus 5, whichever way you prefer to subtract. We square that. So that will be 0 squared plus -7 squared, which is 49. So that's going to give us square root of 49, which is 7. So one of our sides is 7 units long. Okay, next. We'll go we'll do 1, 5, and 5, -2. 1, 5, 5, -2. So that distance will be, subtract our x's, so 5 minus 1 squared. Subtract our y's, -2 minus 5 squared. So we've got square root of 5 minus 1 is 4. Squared would be 16. -2 minus 5 is -7 again. Square that is 49. So that is square root of 65. And that will not simplify. Then we've got, so we did 1 there, 1 there. We got to do 1, -2, and 5, -2. So distance formula, square root of. I'm going to go with 5 minus 1 squared plus negative 2 minus negative 2. So 5 minus 1 is 4. Square that is 16. Plus negative 2 minus negative 2 is 0. Squared would be 0. So we get square root of 16, which is 4. So we have our three sides. And in order for the Pythagorean theorem to hold, it's the two shorter sides squared adds up to be the longer side squared. So 7 is obviously 7. 4 is obviously 4. Square root of 65 is bigger than 7 because 7 squared is 49. And it's actually bigger than 8 because 8 squared is 64. So this square root of 65 is a bit bigger than 8, but not much. So I can tell that this is my longest side. So this one's going to be C in the Pythagorean theorem. And then the other two are A and B, and it doesn't really matter which is which. So after we have our three sides, we're going to check the Pythagorean theorem to see if A squared plus B squared really equals C squared for our triangle. So I'll go ahead and use 7 for my A, so 7 squared. And then I'm going to add B squared, which I'll use my 4. And see if that is going to equal C squared. C squared is my square root of 65. And I'll work through that. So 7 squared would be 49. 4 squared is 16. See if that equals square root of 65 squared, which is 65. And that is indeed true. So we have proven that this is a right triangle. What if they asked us to prove that our triangle was isosceles? Remember, in an isosceles triangle, we have two sides that are the same. Well, the same length, we should probably say. So in that case, we'd be checking to see if any two sides were the same. Remember, equilateral triangles, all three sides are the same length. And in scalene triangles, no sides are the same length. So we could show all sorts of things about triangles just by using that distance formula. Cool. That brings us to the end of 2-1. This one's also scalene, by the way.